right, we're going to consider this topic of transformations. To transform something means to change it, and that's what we're going to do with all of these shapes in both section 3 and section 4. We'll spend the next 2 sections looking at transformations. There are 2 major types of transformations. We have rigid transformations and this is what we're going to focus on in section 3. And then we have non-rigid transformations. Rigid and non-rigid are 2 types. Okay, there are 3 major rigid transformations, 3 types of rigid transformations. We have translations, reflections, and rotations. You've probably heard these terms before, or at least you've heard kind of the simpler term for them. To translate something is to slide it, to reflect something is to flip it, and to rotate something is to turn or spin it. All of these are rigid. These, you'll start with the shape and you're going to move it or spin it or flip it, and when you're finished, the shape will have the same size. It's not going to change. It's just going to get moved. We also call these isometric transformations. An isometric transformation is one that preserves the size of the shape that you're working with. A non-rigid transformation then, oh, I have to sneeze. Okay, a non-rigid transformation is going to change the size. And the type that we're going to look at in section 4 is a dilation. And this is in section 4. We'll study those, okay? But in section 3, we are focusing primarily on just our rigid transformations. So let's start with translations. That's what we're going to look at in this particular video. So first of all, just some terminology when it comes to transformations in general. Here's our first problem, and I'll introduce some terminology as we go. We're going to take triangle ABC and we're going to translate it. So we're going to slide it. We're going to move it 3 units to the right and 4 units down. And you guys did this in class on the worksheet that we gave you when you were finished with your review. And we're going to form triangle. Let me write how you read this. You read it as A prime, B prime, C prime. Okay, that's literally how we read it. But this is the original triangle. I'm going to give you some coordinates for it. It is called the pre-image. It's the thing we start with, the pre-image. This will be our final triangle. So this is the final triangle when we're finished, and it's called the image. Okay, so the final one is the image, the original one is the pre-image, and we're going to move it. So I need to give us some coordinates for triangle ABC. So let's put A at -4, +5. Let's put B at -3, +2. And let's put C at 1, +4 for triangle ABC. All right, so A is located over 4. By the way, for this lesson, you need graph paper, as well as you're going to need your practice book in a few minutes. We're going to practice some problems in the book, and then you'll have some additional practice to do after you watch the video. B is located at -3, +2, and C is located at +1, +4. Remember, X, Y. Okay, so let's go ahead and draw the triangle, and then we'll be ready to translate it. All right, so let's move it. And so what we're going to do is we're basically going to grab each ordered pair and move it 3 units to the right and 4 units down. I want to show you how we're going to write that though now that we're in geometry. So it looked to me like all of you did a really good job moving these shapes when we just gave you a shape and some verbal instructions like that. In geometry, this is going to be written a different way. And we're going to write it with what we call ordered pair rules. So what's our ordered pair rule for this particular problem? It looks like this. Basically it says you take any ordered pair. It's understood that the one that comes first is in the pre-image, and we're going to use this rule. And what are we doing? We're moving it 3 units to the right. And when we move left and right, we're talking about the x-axis, so it's the x-coordinate that's going to change. And going to the right is an increase, so we'll add 3 to the x-coordinates, and then we'll go 4 units down. So we'll take all of the y-coordinates on the original shape and decrease them by 4. This is the ordered pair rule we'll use to come up with triangle A prime, B prime, C prime. All right, first of all, let's slide one of the points. Let's take A and literally slide it. We're gonna go 3 units right and 1, 2, 3, 4 down. This is where A prime is now going to land, okay? And we could do the same thing with C and B, but we also could just use our ordered pair rule. So where did A prime end up? -1, +1. Let's look at where B prime is going to end up without sliding it, okay? The original B is located at -3, +2. What are we doing to the x-coordinate? We're going to add 3 to it. So -3 + 3 is going to give us 0 for the x-coordinate, and we'll subtract 4 from the y-coordinate. 2 minus 4 will leave us with a -2. So B is located here, B prime, excuse me, is located down here at 0, -2. And is that where we would have landed if we had simply grabbed it and gone right 3 and down 4? 1, 2, 3, 1, 2, 3, 4, sure enough. Okay, so let's do the same thing with C. C is at 1, 4. So C prime will be add 3 to the x-coordinate, 1 + 3, that'll be at 4, and we're going to subtract 4 from the y-coordinate, and the y-coordinate is 4. 4 minus 4 is going to leave us with 0. So C prime is over here on the x-axis at the ordered pair 4, 0. Let's go ahead and draw it. Now remember I said that a translation was a rigid transformation and that the shape wouldn't change. So I'd just like to show you that with a piece of transparency paper. And all I'm going to do is I'll trace our original triangle, and then I'll just show you that it remained the same. Okay, so we literally did this. We took it and we slid it to the right 1, 2, 3 units, and then we drug it down 1, 2, 3, 4. And notice it's a perfect fit. The size was not altered in the least. But in geometry, we're going to use ordered pair rules to accomplish that with translations. So let's practice a little bit of that with respect to geometry level type questions. Why don't you turn to page 56 with me? And let's go through questions 2 through a portion of 6. So at some point, you guys will go back and you'll complete this chart here, and perhaps the rest of the problems in this particular problem set. But based on what we just learned, let's have a look. So what does this transformation represent? So we have ourselves an ordered pair rule. So remember, this ordered pair is coming from the pre-image. The pre-image is what we start with, and this will be the final image. When we're finished, this is where it will land. So what's happening to the pre-image? We're going to take that pre-image and we're going to slide it to the right 2, since we're adding 2 to x, and down 5. Okay, so the pre-image will move right 2 and down 5 to form the image. It's going to have the same size though because it's a translation. The size is fixed. All right, so write an algebraic description for a transformation that translates the point xy 9 units to the right and 5 units down. So we simply need to come up with that ordered pair rule. So this is the point we're starting with. We're starting with the ordered pair xy, and we want to move it 9 to the right and 5 units down. 9 right and 5 down. I lost my bright light. I hope you can still see okay. So what are we going to do? We're going to take x, and it's going 9 to the right, so plus 9, and y is going down 5, y minus 5. Okay? All right, so here we're going to sketch this particular problem in number 4. So here's our ordered pair rule. Notice this is segment BC, and we want to sketch segment B prime C prime. So after we move this thing, this is what we'll have. And what are we doing to any ordered pair on this particular graph? We're going to move it, remember, left or right, so it's -4, so we'll slide it to the left 4, and y is up or down, and it's -1, so we're going to slide it down 1. Left 4, down 1. Let's just do that with each of the endpoints. So C is going to go to the left 1, 2, 3, 4, and down 1. And that's where we have C prime, and B will go to the left 1, 2, 3, 4, and down 1, and here's where we have B prime. Why don't we check it? B was located at -1, -1, and B prime, it appears, is located at -5, -2. So if we took the original x, which is -1, and we decreased it by 4, we would be at -5. And if we took the original -1 and decreased it by 1, we would be down at -2. That checks. And the same thing is true for C. The original C is located at -6, 2, and C prime is located out here at -10, 1. So sure enough, -6 decreased by 4 puts us at -10, and +2 decreased by 1 puts us there. All right, so we should draw our new segment. So we end up with segment C prime, B prime, following our translation rule. All right, we're gonna do 5, and I'm just gonna get you started on 6. So number 5, here's our ordered pair rule. Notice x doesn't change, but the y coordinate is going to be increased by 3. So this is only gonna go up 3. It's performed on segment MP, and its image M prime P prime is on the x-axis, where M prime is on the origin and P prime is on -3. What are the original coordinates? Remember, when I say original, because MP is our pre-image, it's what we started with. MP is the final. Okay, so in this case, we know where it landed when all was said and done. M prime is on the origin, and P prime is located over here at -3. There's the segment. How did it get there? This is the final segment because it's the image. So it got there. Remember, x didn't change. That means it did not shift left or right. It only went up 3. So the original, this is the original, or the pre-image, was pushed up 3 in order to form this final image. So where does the original MP need to be? Well, it would have been 3 lower so that we could push it up 3, okay? And the question is, what are the coordinates of MP? So M is located on the y-axis down at -3. That's the ordered pair 0, -3. And P is located at -3, -3. We know that it's still horizontal and they'll be even. Okay? All right, finally, we have a total of, it looks like 7 points down here that we're going to want to transform according to this rule. So we're going to take the rule, and the +2 means we'll move it 2 to the right because that's on our x coordinate, and it'll drop down 3. And then we're going to need to list the ordered pairs. Well, why don't we just move them and see where they land rather than add 2 to the x coordinate and subtract 3 from the y. Starting with t. So t is the original image. It's going to go to the right 2 and down 3. And here's where I have t prime. So t prime is located at -4, +5. You just want to be really careful that you move it exactly the right number of moves, and then that you're reading the ordered pairs correctly. Remember, the ordered pair is x, y, and this is our x-axis, and this is our y-axis. All right, you guys finish number 6, and then in class we'll talk about some of the other problems in this section at some point.